Alrighty, welcome back everybody. It's your main mathematician Shane coming to you live from Summit Academy. In this video, kind of wrapping up towards the end here of the Unit 7, which again we'll kind of talk about everything polynomials. And so our warm-up says what key features are specific to polynomials. So we can say we got the degree, again whether it's odd or even. We have to say the leading coefficient, which is positive or negative. We have, what else is different? So, I could talk about x-intercept, y-intercept, I can talk about domain range. Those are all similar to quadratics as well, but these two main things kind of build in together with our end behavior. So I need my degree, I need my leading coefficient, and then I have my end behavior. So those are some specific, again, that word that says specific, again, I could include other ones, what are key features, but we already did that in our previous lesson. So we're just kind of saying what are specific to that. All right. So what we're talking about is this. So students in writing interpret key features of polynomial and sketch the rough graph of them. So again, some other features you can talk about. It says for a function relationship between two quantities, interpret the key features of a graph and table. So again, this is on the left side here is kind of just our normal quadratic function. Notice how it has that N shape or U shape as well. But we're talking about those two x-axes, or those two x-intercepts, I should say. That vertex is technically that turning point or that point of inflection. So that's normally what we talk about when we're looking at a quadratic function, or not quadratic, when we're looking at a polynomial function. We have multiple points of inflection, which are those turning points. And so we can talk about absolute min or relative min, but for the most part, all I'm going to really be paying attention to is, that degree, leading coefficient, and behavior. All right, so the question we're going to be asking ourselves is why is that the key feature? Why are the key features important? So again, there's list of key features: x-intercept, y-intercept, domain range, and behavior, vertical stretch or shrink, which is that leading coefficient all together, and then our degree. All right, so starting with this equation, I actually have this example on Schoology as well. I have a poster of it made out, but it says without graphing, tell me all the key features of the graph. So let's see here. Well, I can figure out what my x-intercepts are by taking excuse me, the opposite of those two values. So I could say x-intercepts are going to be x equals 2 and x equals -1. Let me say specifically single root at x equals 2 and excuse me, double root at x equals -1. Then we could say our y-intercept. I could plug in when x equals 0, so it would be 0 minus 2 and 0 plus 1. So this would be -2, and then -2 times 0.2 is going to be -0.4. So let me triple check. It says without graphing, but I do want to make sure that we are correct on this. So I can kind of look without the graph, but I can also plug it in. So let me see. I have x plus 1, exponent 2, and Lee said, what's our f of 0? Because that's our y-intercept. So we're very good. Excuse me, Jesus. Our when x is 0, meaning when we were looking for a y-intercept, it's going to be y equals -0.4. Okay. So or let's say y equals -0.4. So that's good. All right, sorry about that. Moving on, what else do we got? We got our, what they have after y-intercept? Sure, domain range. So this we actually do need to look at the graph at. Again, we could figure out what our domain range is, but I want to make sure we check it out. So we're going to say our domain is going to be -infinity less than x less than positive infinity. And then I could say similar for range as well, because if I'm looking at my graph, it goes to the far left, goes to the far right. Again, it does not stop at those x-intercepts, it keeps going past them. But also same thing for range. Our range keeps going down, and it keeps going up. I'm going to say, again, when you're trying to get these symbols, make sure you're hitting that type math button. That type math button will let you type in the pieces you need. So I'm going to say less than equal to f of x, less than equal to, I keep popping up like that, less than equal to positive infinity. All right, so that's going to be our domain range. We said our, what was our one after it? So end behavior, vertical stretch or shrink. So let's talk about that. So let's talk about, I can actually find my degree first. So my degree is going to be 3. Our degree is going to be 3 because we're saying that I have 1x in the parentheses and I have another x in parentheses with that squared. So that's going to be a degree of 3, which is going to be odd. And I can say my leading coefficient, which is a. Again, that number all by itself in the very front of my equation is 0.2, which that is positive. And also too, I can use that old poster from the semester 1 class where I'm trying to figure out, is that vertical stretch or vertical shrink? I'm going to say that's vertical compression or vertical shrink because that is a number, this value for a is less than 1. So I say vertical compression. You can also say shrink if you want to say shrink. Either way works. Let me actually take it out so it's still one line. All right. Now we could say, all right, with those two, I can find my end behavior. And I can pull out my my chart here. All right, on your end behavior chart, I said, what? Let me double check. I said my degree is odd and my leading coefficient is positive. So I say I go to the odd column and then I go to the positive row. I can say, hey, this is actually right because it does have kind of like that N shape, meaning as I go to the left, I go down, as I go to the right, I go up. So I can make sure I copy this down again. I know what these symbols mean, so I can also write those directions. So now let me go back, hit that type math button, and I'm going to say this. I'm going to say, okay, as x goes to negative infinity, comma, y goes to, or you could say f of x if you want to say f of x as well. I also want to make sure that's accessible. F of x goes to negative infinity because I'm going to the bottom left. I say shift 7 to get and then I say x goes to positive infinity, comma, f of x or y, if you want to write y, goes to positive infinity. There. All right, so that's our end behavior. I'm just kind of saying what our directions are. And let me see if there's anything else I need. Degree, end behavior, shrink. No, that's just everything. So again, this is where we would sketch out our graph. So let me go on the next slide. I think we sketched it out. Yeah. So let's try sketching it out. So if you need to go back and watch those videos where we practice sketching those graphs, make sure you do. But I'm just going to follow the same directions. Again, I figured out what the end behavior was. I figured out what my x-intercepts are. So I'm going to plot out those points. So I'm at positive 2. And actually, let's do green. It pops a little bit more. Something like that, maybe. Is this one brighter? Wait, hold on. I always forget which one's brighter. Either way. All right. So I'm going to say positive 2 is going to be one of our x-intercepts, and we have at negative 1. I have a double root, and I actually need to kind of draw it like that. I need to have that N shape because it's going towards the bottom left. Again, draw out your x-intercepts, draw out your end behavior. So I'm going to say, hey, it goes the far left, and it goes up to the far right, and kind of sketch it in between. So it kind of goes something like that. Again, it's not a perfect sketch. It is certainly a rough sketch, as you can clearly see, but I'm just kind of showing what we have here. All right, so now you try. I'm going to let you guys try this one out on your own. Again, it has a extra space here if you need to do any calculations or anything like that. But on this one, what I want you to list off, same idea, even if you need to graph it out and give me this information, that's okay. But you're going to do exactly what we said. We're going to list those key features and sketch the rough sketch, because this is exactly how your question will be on your test. What I'm asking for is I'm asking for the x-intercepts, whatever those are. Again, make sure you write if it's a single root or a double root next to it. Then we could say, what's our y-intercept? Again, when x equals 0. What is our domain? What is our range? What is our leading coefficient? Whether it's vertical stretch or vertical shrink, is it positive or negative? Let me make sure I actually spell that word correctly. That's not what I'm looking for. How about coefficient? There we go. All right. Then we said, what's the last one? Leading coefficient. I am an 89 degree, of course. Is that even or odd? And then I need my end behavior. Again, please make sure you are using that type math button, so that way you guys can type in the symbols they need. Again, make sure you sketch out your graph, sketch your x-intercepts first, draw out your end behavior, so that way you're good. Be sure to ask questions, and as always, super slam that subscribe button.